Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Niku, recently discovered newcomer in solar system. Now Niku is a small object classified as a minor planet, first discovered in 2016, orbiting in the outer reaches of the solar system. Niku's diameter is about 200 kilometers and its semi-major axis or average distance from the Sun is 35.7 AU. Now 1 AU is the distance between the Sun and the Earth. And because it's 35.7 AU, its semi-major axis, then it is called a trans-Newtonian object. And any object with a semi-major axis greater than Neptune's, and Neptune's semi-major axis is about 30 AU, is called a trans-Neptunian object, or a TNO. Niku's orbit has an eccentricity of 0.33 and is therefore highly elliptical. If the orbit is circular, then the eccentricity is 0. So the fact that it's 0.33 makes it highly elliptical. And this makes its perihelion or closest distance to the Sun position only 23.9 AU, and thus well inside Neptune's orbit, whilst its aphelion position or furthest distance from the Sun is very far, 47.5 AU. And we see that illustrated here. This is the semi-major axis, the distance from the center of the ellipse to the edge. And this is the aphelion position, or the maximum distance. The Sun would be at one of the foci of the ellipse, and the distance from the Sun to the furthest position, which would be here, is 47.5 AU, whilst the perihelion position, which is the distance from the Sun to this position here, is only 23.9 AU. And the eccentricity is 0.33. The eccentricity is defined by the distance we see here, which is from the Sun to the center of the ellipse. And that distance is then equal to A, the semi-major axis, times E, which in this case is 0.33. So again, AU is stands for astronomical units, and 1 AU is the distance between the Sun and the Earth. So a distance of 35.7 AU is 35.7 times the distance between the Sun and the Earth. Now Niku's orbit is inclined at 80 degrees to the ecliptic plane, and its orbit is also very surprisingly retrograde. So this is a very surprising thing about Niku orbit, the fact that it's retrograde, and that means that it moves in its orbit in a direction which is opposite to the direction that all the planets in the solar system move, and you can see that here. So if all the planets in the solar system move in this direction, and this would be the direction they will be moving in if this is the north and this is the south, and then Niku, you can see orbital inclination 80 degrees. That means the plane of Niku's orbit is inclined at 80 degrees to the plane, to the ecliptic plane, and it moves in the opposite direction. It moves down in this way, which is opposite to that direction the planets in the solar system move in. Now inclination is the angle an object's plane of rotation makes with the ecliptic plane. An ecliptic plane is the Earth's plane of rotation. But all planets in the solar system have planes of rotation that are very close to the Earth's, or the ecliptic plane. But so Niku's orbital inclination is so high that it almost has a polar orbit. That is, it orbits the Sun almost at 90 degrees or over the poles of the Sun. Niku is also not the first such object discovered beyond Neptune's orbit. In 2008, another TNO called 2008 KV42, and also going by the name Drag, was discovered. This object seems to have a diameter of between 50 and 90 kilometers, so it's a little smaller than Niku, but its orbital inclination is very close to Niku's. It is 77 degrees, and it also orbits in a retrograde fashion. 2008 KV42 has a semi-major axis of 41.5 AU and eccentricity of 0.49. So its orbit is even more elliptical than Niku's. And we see here the representation of that orbit is the semi-major axis, 41.5. The maximum distance from the Sun, 61.9 AU, and its perihelion position, 21.1 AU. So this means that it goes much further out than Niku does, away from the Sun, and also comes in closer to the Sun than Niku does. Now, the fact that these two objects are orbiting in a retrograde fashion and nearly in polar orbits makes it likely that they are new to the solar system. As I detailed in Article 169 entitled Planetary Formation, Comets to Planets, planetary systems do not form as a result of matter accretion, but seem to rather come together piece by piece, with comets becoming planets. This was first worked out by James McKinney from comet observations, which are detailed in his book Planet X, Comets and Earth Changes. These comet observations clearly reveal that comets are not dirty snowballs, but rather protoplanets. Comets become captured planets or moons in star systems. Each time these comets pass through the inner part of a star system, they grow in size, and their orbit becomes more circular, until eventually they become a full-fledged planet, with the heavier elements it captured in its first few passages deep in its interior, and the lightest elements it captured in its later passages forming its atmosphere. Comet observations also reveal that the Sun and all stars form rings or nebular clouds of positive ions around themselves. These rings and nebular clouds act like a capacitor, and so when an object passes through these clouds, it draws a current of positive ions from the nearest capacitor ring, and a current from the Sun's outer negative layer or corona, which contains mainly electrons. All objects in the universe, from atoms to planets and stars and even galactic nuclei, exhibit the same structure. They all have positively charged centers or cores and a negative outer layer. This is what led me to the discovery of how gravity works, and the fact that it has a repulsive part in addition to an attractive part. And you may look at Article 181 entitled Stellar Cores and Deciphering Gravity for more details on that. So here we have illustrated the solar capacitor. We have the Sun at the center. The Sun's corona forms the inner plate of this capacitor. It's negatively charged. And then all the other capacitor plates or rings or nebular clouds of positive ions, and each therefore forms an equipotential surface. A comet, it could be an object other than a comet, as long as it has an elongated orbit, it will pass through different equipotential surfaces and draw a current. It draws a current of positive ions from the nearest ring behind it, and it draws a current of electrons from the Sun's corona. And the meeting of these along the tail is what creates the comet's tail. They also meet around the comet itself. The comets are like asteroids, except they are moving in an elongated or elliptical orbit, and that forms the interaction. The ionization that occurs leads to the coma being produced around the comet nucleus. So this seems to be what creates the comet tails, and also the material that we find in the comet tail is derived from the ring, and that's how we know what's in each ring. Now, the gravitational interaction causes protons to strongly attract each other and electrons to be repelled by the protons, the opposite to the electrical interaction, which results in celestial bodies having a dense positive core and an outer layer rich in electrons. The separation of charge creates an electric potential between the center and the outer layer of the object. This then leads to electric discharges, resulting in light emission and matter creation events, as well as fusion in the star's outer layers. Fusion of protons to helium occurs, as well as of other elements up to iron. The positively charged nuclei are then repelled by the electrons in the sun's corona and either join the core or are propelled outwards from the sun. This is what gives rise to the solar wind and CMEs and result in positive ions being flung outwards. The lightest nuclei from hydrogen to sulfur end up at the furthest nebular ring, which reaches out beyond the orbit of Pluto. Amongst these ions will be helium nuclei. This is therefore where most of the helium produced by the sun will end up. The nearest ring will contain the heaviest nuclei, including iron, and is called a zodiacal ring. It occurs between 0.9 and 1.5 million miles from the sun. There are also 3 stable rings between Mars and Jupiter, containing increasingly lighter nuclei as distance from the sun increases. And here we see the zodiacal ring around the star, and the ring closest to the star will contain the heaviest ions the star ejects, and so it will contain things like iron. And for more details, you may look at Article 168 entitled Electrical Sun and Toroidal Envelopes. Now, because an object entering the solar system or the solar capacitor draws material from the rings, it experiences the drag, which circularizes its orbit. That is, each time it comes in through the inner solar system and passes through the region where there are nebular rings, the drag causes its orbit to become more and more circular. Now, Niku is in a highly elliptical orbit, which suggests it is a new addition to the solar system. In addition, drag caused by the object drawing material from the nearest ring would also pull an object's orbit downward toward the ecliptic plane. So the fact that Niku is in a near-polar orbit also suggests that it is a newly captured object and that it came in from either the very northern or the very southern ecliptic. Now, these small objects are not the only new acquisitions for the solar system. There is plenty of evidence that a system of much larger objects, stellar cores, have entered the solar system in the last 100 years or so, and are now found in the sun's corona as well as in orbit around other planets in the solar system. This appears to be the reason why Jupiter's satellites have gone from 16 to 69. There is evidence that both Earth and Venus have also captured some of these objects. And for more details on that, you may see Article 188 entitled What is Causing the Ocean to Recede All Over the World, and Article 221 entitled Stellar Core Captured by Venus and Debris in Inner Solar System. In addition, there is another star, often referred to as dark star, which seems to have entered the solar system and may have come in from the southern ecliptic. This star, which has been tracked for many years by Terracraft, does not seem to be dead like the stellar cores, as it seems to still have a strong gravitational interaction with the sun. And you may look at Article 208 entitled Incoming Dark Star. Now, whereas the stellar cores can only have a very weak gravitational interaction with solar system objects, at least when they arrive in the solar system. And for more details on that, you may look at Article 210 entitled Stellar Core Gravity, tidal, and G is not constant. G is the gravitational constant, and it is not constant. Now, this star may be a part of a binary star system in which the Sun is the largest star of the two, and may therefore be what some people refer to as nemesis. As its name dark star suggests, it does not emit light, or it does not seem to emit light. It may emit light once it comes into a region of the nebula clouds, as it may draw a current as well. And but this, we may not be allowed to see that. There is evidence, which I've written about in many other articles, that the powers that be are hiding these newer, larger and larger objects in the solar system. Now, so it does not emit light, which is likely due to the fact that it was also invaded by stellar cores, as the Sun has been, and these objects are absorbing so much of the gravitational energy generated by the star in its core, which it does through fission, that it is not able to give off light. And here we see one of these stellar cores drawing matter from the Sun. This is how they draw matter from the Sun. This is why they are drawing energy from the Sun. This matter has high gravitational energy, which the Sun generates in its core, in which it then translates into electric potential between the core and its outer layer, and which then leads to it emitting light. But the stellar core is a dead star, an old star that no longer generates enough gravitational energy in its core, and so it's attracted to the Sun, and I've written about it. I have described in many articles the mechanism why they are attracted to the Sun. But because they have low gravitational energy, they have a gravitational interaction with solar system objects, which is very weak, which is why they can just hover in a position like this close to the Sun without actually colliding with it, without causing a major disruption to the Sun and the whole solar system. And here we see the connection. They make tidal connections with the Sun, which means it's a differential in the gravitational attraction, and it draws matter and therefore gravitational energy from the Sun. And over the years, these objects draw more and more material from the Sun. The Sun is increasingly weaker, and we can see that eventually it will become dark, just like the dark star seems to have become dark. Now, stars and planets all seem to generate energy in their course through the same mechanism, i.e. decay of unstable nuclei. However, stars seem to be able to transform this energy into electrical discharges and light emission, far beyond what planets can, although even planets like Earth have lightning discharges and light emission occurring as a result in their atmospheres. So basically what it means is that stars and planets are basically the same type of object. The difference is stars are a lot larger, generate a lot more energy, therefore generate a much larger electric potential difference between their surfaces or their cores and their outer layers, which leads to much more electrical discharges or lightning. And that's what creates stars' ability to give off light. Now, the dark star must have gone through a process of becoming increasingly weaker and darker in the past, a process which is now occurring with the Sun as a result of the presence of the stellar cores in its corona, drawing matter from it. And you may look at Article 193 entitled Stellar Cores and the Dying Sun for more details on that. So in conclusion, a newly discovered small TNO, or trans-Neptunian object, in a near-polar retrograde orbit indicates it is most likely a new addition to the solar system, and thus provides evidence that the solar system is continuously changing and acquiring new objects. Other objects that seem to be new acquisitions are the stellar cores, or dead stars, which are weakening the Sun and that seem to have affected the dark star in the same way in the past. This dark star does not seem to emit light, but yet seems to be interacting strongly through the gravitational interaction, and is thus not a stellar core, but may be a part of a binary star system with the Sun as the other member. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.